All right, calculus, welcome to your fifth video here. A little trig prereq knowledge for you. Previous video, I gave you these identities. Okay, you should know them from pre-calculus. Here's an example. If theta is in the third quadrant there. Okay, that's going to be important. You guys are going to have to know which quadrant things are in this year pretty quickly. And sine of theta is a negative 8 over 17. Find sine of 2 theta, cosine 2 theta, and tangent of 2 theta. So what you're going to do is I have given you an angle that is in the third quadrant. So draw this Cartesian plane out. Third quadrant, there's theta. Sine is negative 8 over 17. Opposite over adjacent in the third quadrant, both x. This is an 8, 15, 17 triangle, Pythagorean theorem. Both x and y are negative. Again, the radius is always positive. Okay. So sine of theta is negative 8 over 17. Cosine of theta is negative 15 over 17. Why do I want sine and cosine? Well, sine of 2 theta is 2 sine theta cos theta. Really know this one. This is you're gonna see this a lot in calculus, and it's just gonna have to say, hey, I know what that is, okay? This upcoming year. So sine of 2 theta would be 240 over 289. That will not simplify. Cosine of 2 theta. The best one to use is cosine squared minus sine squared, in my opinion. Cosine squared theta is negative 15 over 17 squared. Minus negative 8 over 17 squared. You get 161 over 289. Then tangent is simply the ratio of sine over cosine. Sine 2 theta over cosine 2 theta. Just like before, the 289s cancel. Everything is positive, sine, cosine, and tangent. So 2 theta must be in quadrant 1. All right, must be in quadrant 1. Remember, angles that are coterminal differ by 360 degrees. So you might be like, well, how do I double something in quadrant 3 and get back to quadrant 1? If it was, let's say, 200 degrees. Again, this isn't drawn to scale. Theta is 200 degrees. Well, you double that, you get 400 degrees. Well, 400 degrees is 360 around plus an extra 40. 400 degree angle is a 40 degree angle. All right, coterminal. Folks, you can look at my table. Sorry about that. All right, so I'm going to take you back to this. I don't know if you did this in geometry. It'd be a little bit harder geometry, but definitely pre-calculus. Here's a right triangle, 5, 12, 13. You definitely did that in geometry. Find theta. Find theta. So you know that, sine of theta is opposite over hypotenuse, 5 over 13. Cosine of theta is 12 over 13. And tangent of theta is 5 over 12. Now, let me make sure I think I do a calculator on me here. Definitely did this in geometry. If you're trying to figure out what theta is, you do the second sine, second cosine, second tangent. So that's where you hit. For me, it would be second sine, so sine inverse. What was it, 5 over 13? Yeah, it doesn't matter which one you can do. Tan inverse, cos inverse, whatnot. Oh, notice that nope, I'm correct. Yeah, 5 over 13, that's nothing special. I am in degree mode. Make sure in degree you're looking for degrees. So it's 22.6 degrees. Theta is 22.6 degrees. All right, so you did that a bunch. If you have theta, then this is the complement. I mean, those are pretty standard, like solve the right triangle questions in geometry. Again, you can do tan inverse, second tan, 5 over 12. Cos inverse, 12 over 13. And you get 22.6 degrees. All right. Now, look at this example. So you use cos inverse, tan inverse, sine inverse when we're looking for an angle. So when it's given to you in a question like this, cosine, so find cosine of sine inverse 2 over 3. What in the world does that mean? Well, this is telling you, remember, what goes here, we're talking about an angle. The sine inverse 2/3 is going to give you an angle. Okay? So I'm saying that theta, this angle, has a sine ratio. So it has sine theta has a ratio of 2/3. So I want to know what is cosine of an angle that has a sine ratio of 2/3. So what I'm going to do is I'm going to draw a right triangle. In the first quadrant for now, when we actually meet in person, we'll talk about how we know if something's in the first, second, or fourth quadrant when looking at the inverse functions here. Sine inverse, cos inverse, tan inverse, that is. Okay, so I have a sine ratio of 2/3, and I want to find cosine of that, same angle. So I do the Pythagorean theorem. I get root 5 is positive root 5 in the first quadrant. Cosine of theta then is, so with that knowledge, find cosine of theta. So cosine of theta is root 5/3. So thus, cosine of sine inverse 2/3 is root 5/3. If you try to type all that in, you're not going to get root 5/3, you're going to get a decimal. So yes, you're going to have to do it this way. Okay? I'm going to have to do a lot by hand and without the use of definitely the TI-84s. We'll talk about that early in calculus. All right, so that's a good question. We'll talk about that more. That's actually a decent conversation we're going to have when I am back with you soon. Do want to talk about reference angles. So unit circle just built off of different reference angles. What is a reference angle? So let's say 135-degree angle. So first off, you start here, and angles go counterclockwise. That's how we measure their degrees. So you go 90 degrees. 90 degrees is right here, but 135 degrees would go an extra 45 degrees into quadrant 2. Now, this is an extra 45 degrees. So what I do is I make a reference angle here. Like if I wanted to figure out what is cosine 135, sine 135, I didn't have a calculator, and I didn't know the unit circle. So then I would make my reference angle, my triangle. Remember, the right angle is always formed with the x-axis. There's 90 degrees here. There's 90 degrees. So if this is 45 degrees, I know this has to be 90. It's a right angle. 45 plus 45 gives you 90. So this is 45. This is 45. This is a 45, 45, 90 triangle. Why is it, so it is side root 2, or 1 root 2. Why is it a -1 here? Because x, you're going to the left in the x direction, that is negative. So then I could tell you that cosine of 135 is a -1/√2, which is -2/√2, and so forth. Okay, so reference angles there. There's my triangle. So 100, now we're not talking about like coterminal or anything. We're just talking about reference angles. Let's take a look at 150 degrees. 150. So again, counterclockwise. I go 90 degrees. I still got to go another 60 degrees. Make my triangle, my right triangle, 90-degree angle. If that is 60, this must be 30. Why? Because this is another right angle. There's 90 degrees in each quadrant. 60 plus blank gives you 90. That's 30. 30, 60, 90 triangle. So this time you got -√3, 1 and 2. Side root 3, twice the side. Why is this negative? Again, second quadrant, x is negative. So then that's how we could figure out cosine of 150 degrees is -√3/2. Sine of 150 degrees is 1/2, and so forth. All right, then 120 degrees. This is just how you get reference angles, okay? Because if you don't know the unit circle, this is what you're going to have to do. You know, if you don't have a calculator,